As we begin lesson 5.3, linear relationships and bivariant data, we have to understand what the word bivariant means. So if you look at this word bi represents two. So bi represents two. Now on the other hand, variant is variable. So this is linear relationships and two variable data. The the variables we've been using are X and Y. So rather than say two variable, they say bivariant. Your essential question, which always pops up in your MyHRW, how can you contrast linear and nonlinear sets of bivariant data? The graph of a linear set of data is a single line. The graph of nonlinear set of data is not a single line. So when you have non-linear, there's no line. Think of it that way. Okay, moving on in the same page that we were before, you're going to see that we have an example, and most of it's done for you, but we do fill a couple of things out. So a handrail runs alongside a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. So think of it as you're standing at the bottom of the steps, and that's your handrail. And this is the bottom of your steps, maybe to go upstairs, up to your house, maybe in school. And as you climb up the steps, you get further and further away from the bottom of the steps. So as we climb up the steps, we get further away from the bottom of our steps. And the handrail itself also gets further away from the floor. Show that the relationship is linear and then find the equation for the relationship. To show that it's linear, in your book you have just these points, these ordered pairs. So to show that it's linear, you have to observe that these points fall in a line. So you can observe they lie upon the same line. The relationship is linear, and then go ahead with your straight edge and draw a line through those points. On step 2, they want us to write the equation of the linear relationship. And they've chosen to use that method that I talked to you guys about in class, wrong one. The M equals y2 minus y1 over x2 minus x1. And they're using these two ordered pairs for their x1, y1, x2, y2. So you see they have the y2, 23, minus the y1, 7, and the x2, 25, minus the x1, 5. So calculate 23 minus 7, 25 minus 5, and leave that as a fraction. You will get 16/20. Now, I don't know why that this book has converted the fraction into a decimal. So I'll give you a second to take your handy dandy calculator, take 16 divided by 20. Calculate your decimal. So that decimal is going to be 8/10. Now, just as a little review, yesterday we had those questions to do because I wasn't in class. And if you didn't put a leading zero down for a decimal, it was marked as being wrong. Decimals are never written like decimal point 8. They're never written like that. That is incorrect. You always have a leading zero. But going back to this fraction, if I had asked you to reduce this fraction, what would it look like being reduced? Now, being reduced isn't the same as turning it into a decimal. So if you had to reduce this fraction, what would it look like? And I hope you realized it would be 4/5. You would divide both of these by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. Moving on. Now you have to choose a point and use the slope to substitute the values in for x, y, and m, because you have to find your intercept. So I can see, let me move my block a little bit. I can see a 5 poking out there. So if I see that 5 poking out, I know that they use this point as their x and y, because I see that that's my x, 5, and then my y is going to be 7. So put your y in for 7. Your slope is 8/10. Put that in for 8/10. Next up, you have to multiply 8/10 times 5. So with your handy dandy calculator, multiply 8/10 times 5. And you should get 4. Now to get rid of the 4, to eliminate this 4, I'm going to subtract 4 from both sides. So do that, subtract 4 from both sides. And you should get your intercept as a 3. Now this is my good news, bad news part. Good news is when I was absent yesterday and I gave you those 4 problems, those 4 riddles, I gave you the 4 problems. A lot of you are okay with finding your slope and finding your intercept. That's the good news part. However, the bad news part is for some reason, many people didn't even look this up, this equation. They don't know where your slope goes. They don't know where the intercept goes. Consequently, when they had to write the equation, they wrote it down incorrectly. They actually put the intercept here and the slope here, so it would be incorrect. So ladies and gentlemen, you should have this memorized. And if you don't have it memorized, you should take the time to look it up to know what the equation should look like. It just takes a moment and you'd get all your points. Okay, so this is not in your book. It's just an additional example. So this is not in your book. I might have to move this down a little bit. This is an additional example. The charge for a pizza changes as the number of toppings change. Show that the relationship is linear and then find the equation for the relationship. Now, to show that the equation is linear, my best guess is I'm supposed to present this to the students with the graph in just the blue points without the red line. But there's no other source I can get this from other than my book. Like there's no, like here's the student's copy, here's your copy kind of thing. All I have is what's in front of you. So I'm going to say that to show its relationship is linear, that just requires you to observe that the points fall on the line. Okay, we took care of that part. And then find the equation for the relationship. So you have to find your M and you have to find your B. Now I'm hoping by just using your beady little eyes, you can look and see where the line touches the y-axis. And so that's going to be your B. Yay, it's an easy one. That's your B. Touches at 8. There's no calculations to make for this one, and we love these ones. And so up next, we have to find our slope. So I'm going to choose to use this point and this point for my slope. And I am not going to use the y2 minus y1, x2 minus x1, because I know how to go to grandma's house. I know I rise, I know I run. So let's figure out our rise. I'm starting at 8, I'm going up to 20. So how far am I going for my rise? From 8 to 20, I rose 12. I turn the corner, I see grandma with her cookies, and I run down to grandma. So at this spot, I'm at 0. And I'm going to go all the way over to 8. So from 0 to 8, I went 8. Now this fraction is not in lowest terms, so I want you to reduce it. And reducing that fraction, you divide both numerator and denominator by 4, and you get 3 halves. Sorry, I'm a little sloppy there. And then you jump in and go, here's my equation. Y equals 3 halves x plus 8. And since you got the equation correct, Grandma will give you all the cookies you want. Okay, so up next, we have the your turn problems. So I want you to pause the recording, try the your turn problems, come back to the recording and check your answers. You're so much better off trying these problems on your own and checking answers and then making the changes that you need rather than just copying the answers down. Because guys, if you just copy them down, you're not learning much, except how to copy. Okay, for the first one, for my slope, I'm going to do a rise and a run. So my rise, you have to know what each block is worth on the y-axis, on the vertical axis. So from this spot to this spot is 40, that's labeled. So half in between is 20. So they're counting by 20s. So starting here, I'm going to go up 20, 40, 60, 80. So my slope is 80 over, let's see, I'm counting here by 5s. 5, 10, 15, 20. So I'm counting here and I'm going over 20. So my slope, 80 divided by 20 is 4. So there's my slope. Now if I just observe the line, I can see where it touches the y-axis. It touches the y-axis at 20. So my b is 20. Therefore, my equation is y equals 4x plus 20. Okay, on the other one, you want to see how the y's increase and how the x's increase. So with your handy dandy calculator, 3,600, take off 480, is 3,120. And for your x, 15 minus 2 is 13. I'm going to give myself a place to do some of my work. There you go. Now it won't be so messy. So m equals 3120 divided by 13, change in y over change in x, and that's 240. And I know these answers because I've already done them several times today. Okay, so now for your intercept. So your intercept, y equals mx plus b. And I'm going to use this. Oh, my goodness, I don't want to do that. I'm going to use this first ordered pair. What a mess I've made. So let's see. Y. No, I don't want y. I want 480. Miss Anderson, pay attention. I want 480. That's my y value. My slope is 240. I found that finding my m. My x is 2 plus b. So as a reminder, here's your x value. Here's your y value. And your slope, m, was 240. So multiply 240 times 2. So that'll give you 480. So I want this b to be by itself. So take 480 away from both sides. Oh, I don't give myself enough space. And so my b is going to equal 0. So I have a 0 intercept. In my equation, y equals 240x. And that's as far as we went We do have available to us the MyHRW for lesson 5.3. You can hold off on doing that until we finish up this section, or you can start it. Just do the problems that you can, and then just kind of pause it and say, I'll come back later and finish it. That will be due on Monday, and we will get through this section by Monday. Also, 5.3, lesson 5.3 is the last section in module 5, so expect a test next week. Thank you. Bye.